So, you probably already know me. I'm Alek. You can find me by @MrAlek on Twitter and GitHub and so on. And I also have a somewhat outdated blog at iosnomad.com, which I really should add some more posts to. I work at Doer, and we're helping small business owners to help out with your bookkeeping and other financial administrative work so that entrepreneurs can focus on what they do best. And we have a few customers in the community, which I think is super cool. And I hope that it'll be even more. So today I'm here to talk about TableViewKit. And this was my first alternative title, but I kind of realized there was too much lingo in there. So really, I love UI TableView. I've always loved UI TableView. I think it's been a pillar stone, and it is still a pillar stone of iOS app development. And over the years, it has gained more and more features, and I think it still holds up today as a great UI component. Arguably, you can even see it as one of the success factors of the original iPhone, comparing the smooth scrolling with all the other smartphone devices out there. The only problem with UI TableView has always been its API, and anybody who's been new to iOS development and tried to implement a TableView for the first time has of course experienced all this weirdness with data sources and delegates and keeping track of indexes and index paths. But you have to remember that the UI TableView API was really built for a time when the iPhone had as much CPU power and memory as a goldfish. And a lot of things has happened since then, right? Back then you had to draw all your TableView cells on a flat layer with core graphics because the GPU in the original iPhone was so shitty, so you couldn't compose things on top of each other. But really, even back then, what the TableView could do that nobody else could do was to display lists with thousands and thousands of rows backed by core data databases. And that's really what the TableView was built for. But as you all know, a lot of things has happened since the original release of the iPhone. And nowadays, we have a lot of performance headroom as app developers. And we don't really need to invest that much time and energy into saving CPU cycles. And what we really want to do is to be able to implement all of these cool features in a simple and elegant way. And the TableView has really become also not just a component you use for huge lists of data, but also fundamental building block in building UI with controls and buttons. All right, so this is sadly then where UI TableView falls flat. And I'm sure that you've all seen a TableView data source that looks like this, with a switch case. You look for section indexes and row indexes, and you do some magic there, some explicit for some wrapping of cell classes and stuff like this. And this really becomes hard to manage. It's hard to test. And usually you also have some kind of weird state bool. If bool X is set, then you return 5 sections. Otherwise you return 4. And all of a sudden you have to have all these if and switch statements everywhere in your code as well. And it really quickly becomes unmanageable. So enter TableViewKit, right? So TableViewKit in its concept is really simple. It's really just a reimagination of what the UI TableView API would have looked like if it was released today. So it turns delegates and data sources into view models. And when building this framework, I approached it with a domain-driven design. Just look at what is the table view, what does it consist of? It consists of sections and rows, right? So let's just model those sections and rows and make them easy to work with. So in TableViewKit, you start out with the TableView data source, which is basically your shrink wrapper for the entire TableView API. It takes care of all the index path calculation and stuff like that for you. The only thing you have to know about is that it has these sections. So it has an array of sections. And this is how a section looks like. It has a header view model, a footer view model, and an array of cells. Pretty simple, right? Now when we get to the cell is really where most of the features in a table view is, right? You have selections. You can tweak if in a cell should be selectable or multi-selectable. You can have, and then of course you have callbacks on the selections. You have all these will display and didn't display. So what you can see is basically I've taken every single method or function in the data source in the delegate and just mapped it over. And you're going to see that even though it's a very simple approach, it actually works really well. So let's dive right into a demo. So this is going to be a long one, but I hope that everything will run smoothly as it has for the previous speakers this evening. All right, so here we have an app. It's a really simple app. It gathers quotes. The model is basically a list of quotes. They have a text and an author. An author is a person with a name. So you can see here, I got an array of quotes, and you can imagine that this array might have been fetched from a network API or from a database or really whatever. And now we have these really simple cells. And these cells have been set up as a prototype cell in a storyboard. It's just a standard table view cell, no subclass, no nothing. Really, really simplest case. So I wanted to show you how this looks like in TableViewKit. So this quotes view controller, it inherits from you a table view controller, and it has a data source. So in view did load, we set up that data source with the table view, and that basically just points the data source and the delegate of the table view to our table view data source object. And then we have a function to update the sections, and we have a function to generate these sections. So down here is really where we build the table view up. And as you might see immediately is that these functions, they are pure functions. They just return a value. And every time you want to change something, you just rerun this and regenerate the view models. And then there's a different algorithm that takes care of it. More on that later. So here we have a simple section. Every section and every cell needs to have an identifier. That's for the diffing engine. And then in the cells, we do some functional programming here. We take the quotes, which is this array of quotes, and we map that to cell models using this function. So this is a really expressive way of just converting all these quotes into cells. Now looking at the cell, it has an identifier for the diffing. It has a cell reuse identifier, which is our prototype cell reuse identifier we defined in the storyboard. And it has a cell configurator block where it just sets the text. So this is nothing fancy, right? If we check the type of this cell, it comes back as a regular table view cell. We don't get explicit typing. So let's do this better. So Right now, you only see the code, so you don't see the author's name, and it looks kind of boring with the standard font. So I prepared another cell here with a nib, which has a much fancier code, and the second label. So let's look at that. It's super simple. Just have these two outlets. Now, in TableViewKit, there you can create cell models which are type safe. And in order to do that, we have to do some preparation here on the cell. So I'm going to show you how to do that. So there are two protocols we're going to implement. Since this comes from a nib, we're going to say that it's a reusable view from a nib, and then there's this protocol called data setupable. I really have to work on the naming of some of these things. Bear with me, please. So this reusable view nib protocol, what it does is that it's going to assume that there is a nib name named the same way as the class, and it's automatically going to take care of cell reusage. It's automatically going to register the nib on the table view, so you never have to do that again. And it's using protocol-oriented programming, right? So you don't have to implement anything. It's just you just add the protocol and it works. So for this data setupable protocol, it defines a data model and a setup function. And then there's also an optional function where you can estimate the height for some given data. So let's implement the model. And we're going to make it hashable, so it's so it can be compared. And there's also a second protocol called anyEquatable, which is a type erased equality protocol. So what this means is that when you apply this protocol, equality works on this struct the same way as it did in Objective-C. So you can compare objects of different types. If they have the wrong type, it returns false. It's not equal. If they both have the same type, then it's going to run the equality function. So here, I think I got some. Yes, let's drop this in because I don't dare to type all of this on my own. Okay, so I created a model now. It has a title and a subtitle. The subtitle is optional. To implement hashable, we need the hash value. And then we have this setup function. So in the setup, you get the model in, and you basically apply the view state you want for this model. And now we just have to implement equality. So there's an equality function for the model. If the titles and subtitles are the same, the model is equal. Right. All right, so now our cell is ready. Now let's get back to the view controller. Okay, so instead of this, we can now use a type-safe model. So you see here that we have an initializer which takes a cell type, which is data setupable and reusable, and then it takes a model. So we can use our handwritten note cell here. The ID is still the quote.id, and then the model will actually be, if Xcode works for me. Well, okay, so the model is type safe. And what you can do is to get auto-completion working better sometimes, just do like this, right? You explicitly type the type. So let's add quote.text as the title and quote.author.name as the model. Clean this up a bit. And just to show you that I'm not cheating, let's remove this and just type .init, so you can see that type inference works. It does, right? So we run the app. And now we have these fancy cells. And if you notice, we haven't, we switched the type of the cell, we got type inference working, and we didn't even have to register the nib. Everything just worked. Okay, so let's add some more features. So there's a lot of hidden features in UI TableView and a lot of underutilized features in my opinion. One of them is that cells can have copy and paste. So for a really easy, quick way to share these quotes, let's add a copy function for the cells. Well, lucky for us, it's built into TableViewKit. So if you look down here, in the initializer, in the typesafe one, there is a copy action parameter you can provide. So let's provide that. And you get back the table view, the index path, and the cell type safe, but we don't need any of that. The only thing we're going to do is to go to the UI pasteboard and copy in the quote dot shareable text, which is this little string here, which just wraps the quote in citation marks. So we run this. And we can copy this quote. To show that it works, we go to messages. No, I don't want to send any money. And we can paste it in. And you saw how simple that was, right? Okay, so let's add some more features. Let's show that we also have that the table view is heterogeneous. We can add multiple cell types in the same table view. And let's add insertions and deletions. And let's just show how it works with this unidirectional data flow. So what I would like to do is to be able to share multiple quotes. And to do that, I have to be able to select multiple quotes as well, right? So we're going to start off by just making table view enable multiple selection. And then we're going to add another cell to the top that shows how many quotes you have selected. Oh, that's not the one. Okay, this one. Oh, with horrible indentation. I think I forgot to... No, I actually forgot to include the function declaration. So let's call this selected quotes counter cell. Now let's try adding this in. Okay, great. So now you see that we have another cell type. It's a label cell. This one is super simple. It just has text. And this isn't coming from a nib. It just uses the regular default style, right? Oh, that was still not. Okay, this is the one. Yes, I was fumbling around among my code snippets. All right, so here we go. So this cell is gonna just print out how many quotes you have selected, and it does that by looking for the index paths and for selected rows. So we're gonna add this to the section. So top level cell model plus quotes. Super simple. It's still Swift, but it's in a quite declarative manner that we write code. Okay, so now it says quote selected nil. Okay, we also have to add the selection handlers. So let's see where they are. Okay, so they're before the copy action. and we don't need the table view or the cell or the index path here, but we do need a reference to our cells, because what we want to do when we select is to update the sections animated. And we want to do the same for deselection. So as you can see, like adding this stuff is just a matter of adding some extra parameters to the cell model. And now this is working great. Although I can still tap this cell and select it, and the counter doesn't get updated, but it does when I deselect the other ones. So now it still says optional 1, which is really weird. So let's get rid of that, and let's just disable selection for this model. And we can do that as simple as is multi-selectable false. We'll get to that. So now I can no longer select this cell, and if you notice, this is not just applying the selection style none. It's actually implementing the table view will select row at index path and returning nil, which if you would have implemented this manually in a regular table view data source, you would never have bothered to, because it's just too much work keeping track of that. But in TableViewKit, this is super simple. And yes, so now let's unwrap this. And also, I don't want to show this cell until you actually selected something. So let's do like this. Let's let this function return an optional instead. Let's guard selected quotes count. Let's say that it has to be bigger than 0, otherwise we return nil. So now we get a compilation error here because we can't combine an array of optional cell models with an array of non-optionals. So what I'm going to do is just to flatten this out using flat map. This is, I guess, somewhat of a dirty trick. You could encapsulate this in a function named flatten or something in a much nicer way. But it's not specific to TableViewKit. Okay, so we do that. And now we're not showing the cell anymore, and it animates in and out when we do selection. So this is how simple it is to do interactive UIs in a table view with TableViewKit. All right, so I only showed you some few features because I couldn't have a way too long demo. But as you can see, like some of the benefits you get, you never have to call begin end updates again. So there's a diffing engine in TableViewKit which is gonna keep track of all your cell models, and if all the identifiers are in the same place but data has changed, it's gonna apply the new data on the cell, as we saw with the top cell. And if any of the IDs have either been removed or moved or added, it's going to reflect that. And it also works with sections, so you can remove and move around entire sections, no problem. You also saw that we didn't have to call register class or register nib a single time. You never have to implement cell for row again with all of these nasty index paths. And never ever see an index again in your life unless you really want to. And another big benefit that has been shown in the projects I've been working with this is that you can really compose your data sources. So you can have a generic view controller with the table view, and you get some of the sections from here, from one object, you get some other sections from another object. So it becomes really easy to to share different parts of different views. So for instance, like in the Doer app, we only have a single list view controller, a single detail view controller, and then it's just all composed with different things. So for instance, when we were implementing Predich, we actually only did it once because that's the only time we had to do it in one single view controller, and everything else was split out into providers, which provided with these cells. I could easily just, if you want to have one view with some special on a condition, you add some extra information, or you want to add some like time use cell that gives you some help. You can do that by just injecting that into the array of TableView cells, and it's really simple. You don't have to mess with the data source and indexes. And it's also really easy to embed the entire view controllers and actually other scroll views and other table views. So we had cases where we had an entire collection view that shows a lot of different stuff. Just put that in a cell, into the cell model. It automatically works with updating the sizes. So I should mention also that TableViewKit works with self-sizing cells by default, and you can't opt out of that. So if you have cells that rely on fixed heights, you just add a constraint for that height. And really, when I created this framework, I really had in mind to make the layer thin as possible to avoid really these big complex frameworks that you see sometimes. And I'm not a huge fan of pulling in huge dependencies. So this was a really big consideration when I did this. So if you look at the code, as I mentioned at the beginning, the code is very simple. And it doesn't do any magic at all, even though the end result is completely different from the regular API experience. And since you're working with view models and no longer these weird data sources, which has constraints on how you build up your table view, you can use any kind of paradigm to implement and create these view models. So you can have reactive patterns, or you can have composing bigger view models, or you can just write everything in your view controller. You just do however you want. This is just a thing for your API. All right, so you can find this project on GitHub. Right now it has a really sparse README, and I'm gonna make this a proper open source project with CI and all of the stuff you should add. But you can check out the code already now, and I've been using it in production for a long time, and it works and it's stable, so you know that. All right, yeah. Also, we might be looking for another developer, so give me a shout. Okay, thank you.
Hey. Thank you very much for your presentation. I would like to ask, so as far as I understood, you still need to, every time when you reuse a cell, you still need to return that particular cell with particular class. So it's like usually switch case when you go through each cell which you're returning. So my question is, what is the biggest benefit instead of just using enumeration with a type of integer and returning the type?
Well, really, it's twofold. It's the dynamicism. So if you want to add dynamic objects, your fixed enums with fixed integers doesn't work anymore. If you want to be able to move things around, it becomes a bit messy. You have to change at multiple places. Maybe you have to like change all of your indexes and like +1 and stuff like that. And then also, like for us, I think the biggest benefit is type safety. So everything is type safe. You're never gonna get like a weird exception crash because you forced unwrap or forced cast a cell that has suddenly changed.
Very nice presentation, I must say, and looks like a nice and very thin wrapper around it. And you mentioned something about never call begin and end updates. That's a very bold promise, I must say. So quite often when the content you draw in the content view changes size, you have to use begin end updates basically as a trick to redraw the cell or get it to update its intrinsic content size. Does this mean that we won't need to do this? Is it automatically handled by this engine, or?
It's not completely automatic. So there is instead a notification that you send out from your cell that says, hey, I need a size update. The data source takes care of the begin and updates. Because as you say, it's really the only way to get dynamic size animations working.
Okay, and then a follow-up question on this. Quite often there can be a concurrency between cells that need to redraw. If you have a complex form or whatever, how does that get solved here? If you have like a couple of cells that call the redraw, do you queue the redraws, or do you have something to solve that issue?
The redraw, you mean if multiple cells are changing data, or
multiple cells are changing height, for example, and if you call the begin and end updates for every cell that needs to change height, then quite often there's a race condition and table view crashes. Do you queue up the redraws? How do you handle that?
Well, I think it's just on a dispatch main, so there shouldn't be any race conditions. Because you mean a race between begin and end?
Yeah, it might be that you have begin twice and then start ending twice.
Yeah, that's not going to happen.
Okay. Thank
you. Looks great. Would you be inclined to do the same kind of project for collection view, or would it be work?
Yeah, that's a natural extension, so that's definitely something that I'm gonna do. Yeah.
Great.
Thanks. All right, then I think I shouldn't steal much more time from our last presenter. So thank you.